Hey everyone, so in lesson 8 we're going to focus on graphs of factorized cubic functions. We're going to learn how to sketch cubics that are in factorized form. We're going to look at identifying a repeated factor, and we're going to look at how to do all this on the CAS as well. So as you can notice up here, you'll see that the questions we need to do by hand are these ones, and the ones we need to do by calculator are the bottom ones. So in the previous lesson, we looked at cubics that were of this form here. We talked about the point of inflection and what that was, where the gradient is 0. We talked about, the translations, the dilations, the reflections, and so forth. This is one type of cubic, right, where it's in this form. It's sort of a bit easier to sketch. We know where to move it. We know how to change it based on the original graph, which is y equals x cubed. But the general cubic function in polynomial form is written like this, okay? And we've seen a lot of these polynomials this unit so far, especially when it comes to like long division, or when we're talking about equating coefficients. We've done a lot of that already. But all in all, there is a variety of graph shapes for cubic functions. Okay, so depending on the values of these coefficients, depending on this, which is C, and D. Depending on those values, they could also be factorized into looking like this. So we're just going to look at cubics as a whole now. But let's talk about it a little bit more. So we know that the ones that we looked at last lesson, which were of this form here, only have one x-axis intercept. So just to remind you, let's go back. We had one x-axis intercept here. Or if we sketched, some of these, they just hit the x-axis at that line there. Same here. And same here with all these cubics that we're looking at. Only one x-axis intercept. So some cubic functions have 2 and some others have 3. We all know how to find the y-axis intercept now, similar to quadratics and linear graphs, is just found by letting x equal 0. And if it's of this form here, the y-intercept will be just d if you think about it. So if we let all these x's equal 0, our y-intercept will be just this constant term here. But let's get into it. Let's sketch graphs that are already factorized. So to sketch this graph here, we are going to find all the x-axis intercepts. Okay, and to do that, we let y equal 0. So let's do that. So 0 equals x minus 1, x plus 2, and x plus 1. Okay, so if that's the case, using the null factor law, we can say that x equals 1, negative 2, and negative 1. So let's sketch them. So if x is 1, we've got a point there. If x is negative 2, we've got a point here, and negative 1. Let's see if we can find the y-axis intercept by letting x equal 0. So y equals 0 minus 1, 0 plus 2, and 0 plus 1. So y equals, when you work all that out, negative 2. So we can put a point here as well. Okay, so now we know the intercepts. We just need to figure out what the actual graph looks like. So what we're going to do now, and this is something you've probably never had to do before, but we're going to check to see on this graph, if we substitute certain values. So if I just say, I know that these are my intercepts here, negative 2, 1, negative 2, negative 1, and 1. I want to know whether or not the graph is above or below the x-axis on the left-hand side of negative 2. I want to know also whether the graph is going to be above or below the x-axis in between these 2 points. Okay. I also want to know, I'll do the same color. I want to know between here and here, between these other two intercepts, whether the graph is going to be above or below the x-axis. So whether it's up here or down here. And then at the end, I want to know where the graph is going to be above or below the x-axis. Okay, whether it's up here or down here. Okay, so I'm going to rub all that out. So we're going to break it up into 4 parts. So everything on the left-hand side of -2 is the graph above or below the x-axis. What would be the y value, in other words? Between here and here, same thing. Between here and here, same thing. And from here onwards, what is it? What is the value of y? That's how we do it. We work out the value of y. So let's just rub all this out to make it neat. So, when x is less than -2, let's just say, let's pick a number, -3. Substitute that -3 into the equation and we get y equals -8. So this means that y is less than 0. So if I go back up here, I know from this section here, okay, and onwards, my graph is going to be down here, below the x-axis. Okay, y is less than 0. So let's do that for all the other 4 sections. Okay, so for the next 2 sections, between x is -2 and between x is -1. So between here and here, that's how we write it. You write that neatly. Okay, so between -2 and -1. Okay, so between here, these 2 x-intercepts, is my graph above or below the x-axis? Is y greater than 0 or less than 0? So we substitute, let's pick a number between those 2 numbers. Let's substitute -1.5. We get this number here, so y is greater than 0. Okay, so that's for this part here. Now let's look for the next section between -1 and 1. Okay, let's say when between -1 and 1, let's choose x equals 0, nice easy number. Y would equal -2. Okay, so y is less than 0. Okay, so that would be in this section here, below the x-axis, somewhere here. And then at the end, everything greater than 1. So when x is greater than 1, let's pick 2, nice easy number. Could pick 3 if you want, 4 or 5, but nice small number, make it easy to work out. Substitute 2 into the equation, you get y equals 8. So y is greater than 0. So what does this tell us? Go back down here. Let's put in the points that we had. Okay, these were our x-intercepts. And this was our y-intercepts. We know that it starts off below 0, then it goes above 0, below, above. So let's not perfect the drawing just yet. We'll do that later on, but it's going to look something like this. Okay, so here onwards, the graph is below 0. Between here and here, the graph is above 0, the y value. Don't know why that's not rubbing out. And then the next section, it's below 0, and then the section at the end, it's always above 0. So this is essentially a cubic of the polynomial form. Now, other things we would need to know to make this graph perfect is what is the value of this turning point and what is the value of this turning point. Okay, and that way it would make it a little bit easier for us to sketch this. It could very well mean that the turning point is actually there, but we need to know this information and we need to use the CAS to find that out. But for now, this would be good enough. So the cubic that we just did was already in factorized form. However, if it was not already in factorized form, but of the polynomial form, then the cubic would need to be written like this. And what you'll notice is that we're looking at the coefficient of the x cubed value. Because it's a cubic, we're looking particularly at this coefficient. The coefficient of this x cubed is just the number 1. And because that number 1 is positive, we know that, well, you're going to learn now that when it's positive, the graph has a form like this. Okay, so this is a positive cubic. So I'm going to write positive here. And if it's negative, as you can see below, it goes the other way. Negative. Okay, so maybe it's worth writing that in your book. What you'll notice about the difference between positive and negative is at the very start of the cubic, you can see here that this is going upwards, so that makes it positive. And at the very start of this cubic here, it's going down, so that's what makes it negative. Remember, always looking left to right. So now let's see what happens when the coefficient of x cubed is negative. As you can see here, this is what the graph would look like. It is essentially the exact same graph, okay? Except since the coefficient of x cubed is negative, we start off with a negative gradient. Like we said, at this stage the location of the points is the turning points is unspecified. However, it is important to note that unlike quadratic graphs, the turning points are not symmetrically located between the x-axis intercepts. How to determine that we'll show you later, but we can also sketch it in our CASs. What that paragraph means here, okay, is that usually, well, when we looked at quadratics, we'd know that the turning point would be exactly halfway between two intercepts. So that's not always the case now. Okay, so you'll see here, as I drew this, I'll use green, the turning point could very well potentially be not halfway between -1 and 1. It could be just a little bit past it. Okay, it could also be exactly here. It could, but it's not always exactly halfway between two intercepts. So that's what that paragraph was saying. Okay, so a sign diagram is very similar to what we just did. It's figuring out whether or not it's above or below the x-axis, or whether y is greater than 0 or y is less than 0. But using a sign diagram requires that we have to find the x-axis intercepts. Alright, so if we were to sketch this cubic here, there's a few things we would need to do first before sketching. We would need to factorize, and then we would need to get our x-intercepts in order to help us do what we just did before. So rather than going through all this again, remember how we said you can choose whichever one you feel comfortable with, whether it's long division, which would be this one here, or whether it's equating coefficients, which would be this one here. Okay, you can choose either which way you want, but instead of going through it, I'm just going to fill it out for you right now. Okay, so here we go. The long division's already been done for you. Equating coefficients already been done for you. When we divide or factorize, we eventually get to this point here. Okay, x plus 1 is a factor. And eventually we get x squared plus x minus 6 from up here, or as you can see from these b and c values. Eventually, we know that x squared plus x minus 6 can be factorized into x minus 2 and x plus 3 using the cross-bridge method or any other method you're familiar with. And then, obviously, with that, we can get our x-intercepts as -1, 2, and -3 using the null factor law. So, we're going to do exactly what we did before. I'm going to write up here the 3 x-intercepts that we have. We have x-ints are negative, I'm going to write them in order as well, -3, -2, And we also have, sorry, not -2, we have -1. And we have 2. So I'm interested in 4 sections, okay? I just want to really drum this home. I want to know everything less than -3. I want to know everything between -3 and -1. I want to know everything between -1 and 2. And I also want to know everything bigger than 2. Okay, so they're the 4 sections. So let's write them all down straight away. When everything is less than -3, when x is between -3 and -1, when everything is between -1 and 2, and when everything is bigger than 2. Okay, so something is less than 3, let's pick -4. Substitute that in, you get -18. So that would be y is less than 0. Between -3 and -1, let's pick a number right in the middle, -2. That would give us a number bigger than 0, so that's y is greater than 0. Between -1 and 2, let's say x equals 0. So substitute that in, you get -6, so that's less than 0. And if you go anything bigger than 2, let's say x equals 3, you get y is bigger than 0. So what is this sine graph we keep talking about? Okay, it's just another way of doing what we did before, really. So we know that the first one was everything less than -3. So everything less than -3 is below the x-axis. Okay, so below the x-axis. Maybe I'll draw that a little bit higher, actually. Below the negative axis. There you go. And then once we get to -3, and go anything between -3 and -1, we see here that y is greater than 0. So I'm going to draw that at -3 we go above it until we get to -1. It's pretty much just a sine diagram way of doing what we did before. Just a little bit of extra things to help us visualize what it's going to look like. The next section is here, okay, between -1 and 2. So at -1 we then go below 0. So here we're going to go below 0 until we get to 2. And then at this point here, it goes back above 0. So in other words, the graph is going to look something like, we've got an x-intercept at -3, we've got an x-intercept at -1 and at 2, and we know that it starts below the line, goes above, hits this here. I've got to find out what my y-intercept was before I sketch this. Well, just looking here, my y-intercept is when x equals 0. So 0 cubed plus 2 0 squared minus 5 0 minus 6. So equals -6. So I know that when I go down here, I want to hit that -6 there. So I'm going to keep going and then eventually come back up. Again, I'm not sure whether the turning point is at -6 or whether it's here, but we will get to that in later lessons. Or we can just get to it right now. So the next page is about using your calculator and knowing where to find the turning points. So let's open up our calculators. So when we get into our calculator, we press always, when you start a new document, Control-N, and you should get to this point here. If it says save or not save, you never really need to save anything, so just press no, and you click Add Graphs. What we want to sketch now is this graph here. So we want to type in x cubed plus 2x squared minus 5x minus 6. So that was the one that we just looked at. So x squared, x cubed plus 2x squared minus 5x minus 6. Now you're going to sketch it and you're not going to really see everything, so it's important to zoom out. So menu, window zoom, zoom out, and it's always good to use box. So menu, window zoom, box, and just click the sections that you want to see and ignore everything else. So how do we check the turning points? So let's press menu, analyze graph. Now depending on whether it's a minimum or a maximum, you want to use one of these two. So here we have a minimum, and for a maximum we just click on the left, click on the right, same thing as we did before. So now we know that what the decimal values are. So if I was to go up and fix it now, okay, I would sort of double check before I sketched anyway, but I will double check that this would be at negative 2.12, so that I guess should be shifted a little bit this way. I'm not going to fix it up now, but you would know that before you sketched it. And the turning point, I've clearly drawn it poorly here, so maybe what I'd do is I'd fix it up and I'd go through the 6, but I'd make sure that the turning point is at just before 1, so 0.7. Go here, and then the turning point there. Obviously a bit better, but this is at least closer to negative to 0.7. So just having a bit of extra detail to know where the turning point is and so on. Let's now talk about repeated factors. Okay, so repeated factors are essentially where the turning point is the x-intercept. Okay, if that's the case, in this case you would notice that it's because a little squared here, x minus 1. If we were to solve that for 0, so if we were to write 0 equals x minus 1 squared, x plus 3, well then my two factors would be, well, this would give me x equals negative 3. This would also give me x equals 1. Because it's twice, that's the squared sign there, that's the indicator that this is the turning point as well as the intercept. Okay, so that's a repeated factor. You don't need to copy this down, but that's just a bit of a side note. If the factorized cubic has a repeated factor and another linear factor, there are only two x-axis intercepts, and the repeated factor corresponds to one of the turning points. So let's have a look at this one here. To find the x-axis intercepts, let y equals 0. So here, 0 equals x squared, x minus 1. So we know that x squared equals 0, and x minus 1 equals 0. So this tells us that x equals 1. And this tells us here that x equals 0. But this is a repeated factor. Okay, so because the repeated factor is x squared, there is also a turning point at x equals 0. The y-axis intercept by letting x equal 0 is just y equals 0 squared, 0 minus 1, and so y equals 0. So how do we sketch this now that we know everything? Well, let's look firstly at our x-intercepts. Well, one of them is going to be at 0, and we know that this is also a repeated factor, and the other one's at 1. And so let's think about how the direction of this graph will go. We know that the x squared times the x gives you a positive x cubed. Okay, so if that's the case, we're going to be going in a positive direction. Okay, so because we're coming from up here, that's going to be our turning point, and our intercept's going to go down, and it's going to go up like that. Okay, so that's what a graph would look like with two x-intercepts. One of them would be a repeated factor. There is possibilities of having one x-axis intercept. I guess those cubics that we saw in the previous lesson in, the point of inflection form. But here, more generally, cubics of the form y equals x minus a cubed have only got one x-axis intercept. Some other cubics also have only one x-intercept because when they're factorized, they're found to only have one linear factor, with the remaining quadratic factor unable to be factorized further. We'll see what we mean by this. So let's have a look at this graph here. Let's find the y-intercept first, and let's let y equal 0. Okay, so y equals so that eventually gives us 5. Ideally, we would like to factorize this further to get it down into 2 more brackets to see what the other 2 factors are. But I can't think of any numbers that multiply to give us 5, but also add to give us 4. So the other options are to do the quadratic formula or to complete the square. But before we do any of that, let's just check the discriminant to see how many x-intercepts this quadratic has. And we looked at this last lesson as well, but we know that when we work out the discriminant, we know that it's b squared minus 4ac, so that would be 4 squared minus 415, which gives us 16 minus 20, which gives us -4. Okay, so the discriminant of the quadratic is negative, which is the reason why we have 0 solutions, or no solutions. So the quadratic cannot be factorized further, therefore we stay as is at negative x minus 1, x squared plus 4x plus 5. Which means that this here is our only factor that can give us an intercept. So hence there is only one linear factor and therefore only one solution. Therefore, if I was to substitute that bracket and let it equal 0, I would get x equals 1. A CAS calculator can be used to find the turning points, okay, where the coordinates of the second point are given to 2 decimal places. So let's just look firstly, where is our only x-intercept, which is here, x equals 1. Here is our y-intercept, but that doesn't really give us much shape. So we do need to know where the turning points are. Once we use the CAS and sketch it like we did here, we would eventually figure out that the turning point is here, and the turning point would be at negative 1.82291. So where's that roughly? I would say about here. Okay, so we know that it is just by looking at the quadratic, which is here, just highlighting just so you know where I'm looking, we see that it is a negative cubic. Why? Because this negative multiplied by that x gives you negative x. Negative x times negative x squared will eventually give me negative x cubed. Okay, so we know it's a negative 1. So let's just remind ourselves what a negative 1 looks like. Negative starts off by going downwards. Okay, so that's negative, and positive goes like that. Okay, so if the negative goes downwards, well then it's going to come from here. That's going to be the turning point, and that's going to go down there as well. Sort of butchered that a little bit. I'm going to try that again. This is my turning point, so I might draw that flat line there. This is also my turning point, so I might draw a flat line there. That's a bit better. So at this stage of the course, you cannot determine all the features of a graph of a general cubic polynomial by hand, but as you can see in this lesson, we use the CAS calculator to help us find the turning points, and that's what really helped us to sketch it properly. But we can find the x-intercepts and the y-intercepts by hand, and that really helps us. So that's that for that lesson, and remember what we said about the questions. There's a lot here, quite clearly, but these are the ones you need to do by hand, and these are the ones you need to do by CAS. Thank you and good luck.